original size. But what's much more interesting is how our production capacity has grown. In 1990, team produced 1,835 trucks. That's their first year. Today, we produce nearly 33,000 trucks, 18 times more than what we produced in that first year. I'm a Peter Drucker disciple. Peter Drucker perhaps is the best management guru of our times. He says, a product is not quality because it is hard to make and costs a lot of money. Customers pay only for what is of use to them and gives them value. Nothing else constitutes quality. According to a Reed Research study, and we don't have J.D. Power study, customers rank Toyota lift trucks as #1 in quality and #1 in value in the last 3 years and as long as the study has been conducted. And we have Toyota production system to help us for achieving that honor. My point is this team is clearly a very productive Toyota plant, much like the majority of the manufacturing plants that are represented by you here today. Well, as many of you know, U.S. manufacturers have made enormous gains in productivity over the past 2 decades and are continuing to do so. I recall those days back in the 80s when U.S. productivity in various industries started falling behind the Asian countries. Many of the so-called experts were predicting its slow demise. Most of the manufacturing jobs would eventually go offshore where labor, raw material costs were lower, was the claim. What's interesting is that today you hear the same claims about service sector jobs. Well, these claims are well known and well publicized. What is much less publicized, however, is the fact that U.S. manufacturing productivity doubled in the last 20 years, from $89 per hour to $178 per hour per person, indexed to productivity of 1992. In many industry segments, U.S. companies are now world-class and setting the pace. Through cost-cutting, downsizing, re-engineering, lean manufacturing, America now boasts some of the most productive manufacturing plants in the world. A great number of these plants are represented here today, and most of you have been in the manufacturing industry for quite a while. In other words, you are all have had a hand in helping achieve these very impressive productivity gains in the U.S. You've helped America be what it is today, a leading nation of the manufacturing productivity. So, does this mean that we can now rest on our laurels? Hell no is my very, very clear answer to you. We must continue to improve, especially in light of the continued threats to U.S. manufacturing. If we even slow down our pace, we can get passed by the EU and Asian countries, especially industrial giants like China of today and India of a few years from now. Our challenge is to take our already highly productive plants in the U.S. to new heights. Last year, in a joint Industry Week and Bearing Point survey, senior manufacturing executives, and maybe perhaps some of you here, rated productivity as more important than cutting costs. A proven way to attain continuous productivity improvement while lowering costs simultaneously is by using something that's a very big part of all of our daily lives. Obviously, that's the Toyota Production System, or TPS. And up till now, I haven't said anything about TPS. Are you still with me now? All right. Today, I will review TPS as we know it and share with you some of the history behind its basic principle. It's really interesting history. I'll give you examples of how TPS has grown beyond manufacturing to incorporate lean thinking into businesses both inside and outside of manufacturing here in North America and elsewhere. Here's a little bit of history. In March of 1937, Toyota Motor Company was formed, and the construction of the Koromo plant was decided upon at Toyota Automatic Loom Works board meeting. That was the parent company. But before construction began, Kiichiro Toyoda had formulated a flow production system instead of a lot production system for Koromo's production line. Kiichiro's manual is a really impressive one. It was a full 4-inch thick manual. What Kiichiro had in mind was to produce needed quantities of required parts each day. Now, to make this a reality, every single operation had to be converted into a flow production system. Kiichiro referred to this as the just-in-time concept. According to A.G. Toyoda, our ex-chairman of Toyota Motor Corporation, the system and the concepts that Kiichiro had taken such pains to teach and instill in Toyota associates was totally dismantled soon after the start of the World War II. Following the war, Taiichi Ono, former executive vice president of Toyota, revived and further refined the system using the now legendary Kanban cards. By 1975, the production method that has been conceived 4 decades prior was fleshed out. When people at Toyota, this is really interesting, when people at Toyota wanted to refer to it at that time in the 70s, they called it the mustaches method. They didn't have a name, in deference to Ono's nickname. Since the mid-70s, TPS has gone through several upgrades within Toyota and continues to do so. In fact, this production system didn't even have its name until others who tried to understand why Toyota is making so much money or being so profitable started calling it the Toyota production system. The basic purpose of our company, I want to start there as the foundation of TPS. The basic purpose of our company, or the reason for existence, is as follows. Please follow the slides if you would with me. First of all, we will see at the bottom that our company must make profit to continue to exist or survive. Survival, of course, is number one. Once these needs are met, then in ascending orders, we take care of the employees, the society, then the customers. The basic philosophy of TPS is that no cost reduction, with no cost reduction, there is no profit increase. On the slide, you will see that profit equals sales price minus cost. Profit can be increased by either raising sales price or by reducing cost. If one believes that sales price is determined by the customer based on the product's perceived value, then cost reduction is the way to improve profits. This is one of the fundamental precepts of TPS. The components of cost are very common among the competing companies. All of them have the same raw material cost, parts cost, labor cost, energy cost, and so on. But extra cost is introduced by differences in the production method. Therefore, cost depends on the production method. Traditional lot size production creates waste. Continuous flow production reduces many different kinds of waste. From this point on, I'll call it muda. Therefore, continuous production generates lower production cost. Another additional philosophy is that muda exists everywhere. For example, if you break down an operator's motion, what he does, at the first level, we find that there's work and then there's unnecessary motion, or A in the slide. Then when we break down the operator's work now, we find B, which is incidental work, which is non-value-added work, but needed under the present work conditions. In this particular slide, operator's total work motion, off that total work motion, net work achieved is only C. I give you just some of the fundamental philosophies. So based on these fundamental philosophies, JIT was developed. Again, going back in history, in 1937, Ford and GM were selling trucks in Japan to their dealers for around, astounding number, 2,400 yen. Anybody wants to guess what that in dollars today is? Will be around $20. This is 1937. Kiichiro argued that by using continuous flow production and reducing the muda of unnecessary motion and incidental work, as we just described, Toyota could produce trucks for 1,850 yen. By supplying the dealers at 2,400 yen, they would make a handsome profit. And this is the start of the Toyota Motor Corporation. Taiichi Ono described the environment at that time as such. Above all, one of our most important purposes was increase productivity and reduce cost, again at the starting point in early 40s. Now, let's travel to today, and we today at Toyota define TPS as such. TPS is a system of manufacturing that results in the elimination of waste and full utilization of human resources, equipment, and material. On the screen, you will see a visual representation of the framework of TPS. At the top, you will see the highest primary goals of highest quality, lowest cost, and shortest lead time. They're all simultaneous. Just-in-time and Jidoka are the two pillars that support these goals, and on the foundation is represented by Haijunka, standardized work, and Kaizen. Most of you know these terms. Highest quality and the lowest cost, all those somewhat self-explanatory, needs to be technically defined. But here, one can benchmark competition to determine the lowest cost and the highest quality in its own class or category. But what do we mean by the shortest lead time? We define lead time as the time between production plan, production, distribution, and sales, the total time. Another way of looking at this is the time to collect money between sales and production plan. Production lead time, I should say, equals the processing time or the assembly time plus stagnation time. Now it's here very important to elaborate on this concept of stagnation time. Here is an example of a stamping process. From the coil through blanking and stamping, a part is produced for assembly. The total production lead time is 600 minutes and 2 seconds, where the processing time is only 2 seconds and stagnation time is 600 minutes. Reducing stagnation time is then key to shorter production lead times. The root causes of stagnation in the production process are 4. Large lot size, complicated production flow, a very weak belief in the parts of production people that production pace must keep equal to sales pace, and I'll elaborate on that. And finally, poor methods of conveyance, what we call logistics today. Thus, to obtain the shortest production lead time, we must address all of these 4 areas. Let's take a look at how this large lot size prolongs lead times. In this example, production lead time is 10 days, even though processing time is 1 hour. Here, the last piece will be used 10 days and 1 hour later, and the sales pace of the following process becomes apparent only after 10 days. So you have to kind of stay with me on the slides, so please follow the slides. And try to shorten it as much as you can. A better process for this case would be to have a 1 hour lot size. This leads to a shorter lead times, less inventory, and less risk of market change. Here, the last piece would be used only 2 hours later, which means the sales pace becomes apparent only after 2 hours. Now let's take a look at how complicated flow prolongs lead times. First, on a macroscopic flow or relying on outside vendors. In this example, relying on outside vendors more often than necessary is wasteful and prolongs lead time. By producing it in-house with inexpensive machinery, this company can theoretically decrease its lead time by 5 days. In the microscopic flow, even when production is completely internal, an overly complicated flow leads to stagnation. The flow of parts is inconsistent, and it becomes difficult to tell when finished goods will come out of the line after the first production instructions are given. Furthermore, with so many elements on this slide, it's very hard to find where the real muda is. So by straightening out the process flow and producing parts one at a time rather than a batch, this company will decrease the lot size, eliminate inventory stock, and control costs.